75 years ago, a British expedition sailed south from New Zealand to the icy Antarctic. In command, Captain Robert Falcon Scott of the Royal Navy. Spirits were high. They were off to claim new territory for the king, the country, and the empire. They didn't know that Scott's big rival, Roald Amundsen from Norway, was a month ahead of them. When Scott reached Antarctica, he found endless miles of icy waste, howling winds, bitter cold. Regardless, he struggled on, determined boldly to go where no man had gone before, to the South Pole. But Amundsen got there first. The Norwegians reached the pole at 3 p.m. on the 15th of December 1911. Scott and his team were still battling with the cold 360 miles away. When they finally reached the pole, a month too late, there was nothing to do but turn round and head for home. And that was when they really felt the cold. They suffered the agony of frostbite on their faces and their hands. In the end, they froze to death. Scott and his men had lost the race and their lives. What went wrong? Could it have been their clothes? When he was getting ready for the expedition, Scott went shopping for his clothes in the West End of London. In the smart streets near Piccadilly Circus, he found the latest thing in explorers' clothing: woolen underwear, flannel shirts, canvas jackets, and balaclava helmets. Underneath their canvas jackets, they wore woolen sweaters. On their feet, several pairs of socks. They believed that many layers of thin clothes would keep them warm. Roald Amundsen dressed quite differently. He wore fur clothes like the Eskimos. Even today, some Eskimos still wear polar bear skins. Without clothes, a warm body quickly loses heat and gets cold. The job of your clothes is to stop the heat escaping. In other words, to insulate you from the cold world outside. Watch how quickly the yellow disappears. This is what happens when you take your glove off on a cold day. In this Thermo Camera film, yellow is warmest, red next, then pink, blue and green. The palm has already cooled from yellow to red. Skin quickly loses heat without insulation. Animals that live in the Arctic don't have naked skin. What do they use for insulation? Do you think Scott could have learned anything about keeping warm from the polar bear? Or from the reindeer? Or even from the Arctic fox? What keeps it so warm? When it's really cold, animals use extra tricks to try and keep themselves warm. Sometimes they huddle together, like the muskox in northern Canada. And these sheep in the dales of Yorkshire. Why do you think huddling together might help? Sometimes we can learn more by looking at the animals with the Thermo Camera, a special kind of scientific eye. Hamsters are inquisitive, but they also like to keep warm. What can we learn by looking at them with the Thermo Camera? When they stopped for the night on their way to the South Pole, Scott and his men tried to keep warm by huddling together in their sleeping bags. But what about the bags? Were they warm enough? How can we tell scientifically whether their bags provided good insulation? The sleeping bags Scott used were made from reindeer fur. To test a reindeer fur sleeping bag, these scientists are taking it into a special cold room. They put a barrel of warm water inside and wrap the bag carefully round it. There's a thermometer in the lid to measure the water temperature. The fur bag and the modern bag on the left are left to keep the barrels warm. Meanwhile, the temperature in the room drops to an Arctic -28 degrees Celsius. The results are plotted as a graph of temperature against time. The water cools quicker in the fur bag, as the yellow dots show, which is the warmer sleeping bag. How could you use this method on your clothes? To test the insulation of their anoraks, these scientists are using conical flasks of warm water. One flask is insulated in the sleeve of the anorak. The other is left out on the bench.
What's your 7 at start?
They measure the temperature in both flasks every minute. Why do they have two conical flasks? What's the other flask for? Why do they take the temperature several times? Wouldn't one measurement be enough?
33. 38.
Graphs of temperature against time show that a flask without insulation cools quickly. The flasks insulated by anorak sleeves cool more slowly. How can you tell which is the best anorak? The warmest anoraks of all are filled with eider down, the soft underfeathers from eider ducks. The eider duck keeps her eggs warm by lining the nest with her own down. In Iceland, collectors take some of this down to make filling for anoraks. They leave behind enough down to stop the eggs from getting too cold, and they're careful not to frighten the mother duck. Eiderdown filling is used in the clothes worn by climbers on Everest, the highest mountain in the world. As well as the cold, mountaineers have to put up with icy winds that howl through the Himalayas at 100 miles an hour. Why do you think it's important that the outer layer of their clothes should be windproof? Penguins cope with biting wind by lying down to keep out of the worst of the blast. Eskimos usually wear their sealskin jackets fur side in so that the leather keeps the wind out. How windproof are your clothes? Another problem we all need to know about is the Bellows Effect. Body movements can squirt warm air out of your clothes if they don't fit tightly at the edges. How do your clothes deal with the Bellows Effect? Why do you think Eskimos have fur at the collar, cuffs and waist? And what is it about fur that makes it such a good insulator? How could you test it scientifically? This is an Eskimo coat of reindeer fur. Long, thick hairs with lots of air trapped between them. Air is a good insulator. Air trapped in the fur makes it very warm. Scientists measure insulation in togs. This reindeer fur is on a tog meter. There's a warm hot plate underneath, and this probe will measure how much heat comes through. A good eiderdown duvet has a tog value of 11 or more. An Eskimo coat, 8 togs. Scots clothes, only 1.5. If air is a good insulator, then a string vest ought to be very warm because it traps lots of air. How could you test it? First, vigorous exercise to warm up the skin. Next, put on half a string vest and a t-shirt on top. Half of his t-shirt looks much colder because the air trapped by the string vest is keeping the heat in. So string vests do work. Air is a good insulator as long as it's trapped near the skin. But Arctic animals don't always stay dry. What happens to insulation when things get wet? Why is it that wet clothes don't feel warm? This is the material used to fill an anorak. When dry, it has a tog value of 5. But when it gets wet, the tog value drops by half. Why are wet clothes worse insulators than dry ones? Why do you think it's important to keep your clothes dry? And why is it dangerous to stay out in the cold when your clothes get wet? We know that air is a good insulator. How do builders use this idea to keep a house warm? First of all, the walls. Modern houses are built not with one wall, but with 2. How do you think cavity walls help to keep the house warm? Old houses can often be made warmer by filling the gap with special foam called cavity wall insulation. In this new house, the insulation goes inside. The walls are lined with panels which have a sheet of foamed polystyrene on the back. This polystyrene is a good insulator because it's made as a solid foam. All the little bubbles are filled with air. You can see how well polystyrene keeps heat in. The tea on the left has warmed up the cup so that the outside of the cup is as hot as the tea. On the right, the tea is hotter. It's yellow on the scale. But even so, the outside of the polystyrene mug stays cooler than the cup. In houses, a quarter of the heat is lost through the roof because hot air rises and takes the heat with it. Look at a house with the Thermo Camera, and the roof looks warmer than the walls, so they insulate the roof to cut down the loss of heat. The insulating material is fiberglass, very fluffy, with lots of air trapped between the fibres. Why don't they use some other material, like cotton wool? What about the windows? In this house, the kitchen window looks warm, even though it has double glazing. What do you think will happen if you open half the window so that the left side is only single glazed and the right is triple? So, was Captain Scott let down by bad insulation? Was Amundsen better off in his fur clothes? What fair test will compare the two with modern mountaineering equipment? Remember, Scott had many layers: flannel trousers, woolen sweater, canvas overtrousers and jacket. Amundsen relied on Eskimo clothes like this reindeer coat.
Okay.
Before going into the cold room, these scientists put temperature probes under their armpits so that their skin temperatures can be recorded. Inside, a giant fan simulates the icy Antarctic wind. The room is still at -28 degrees Celsius. And their temperatures are beginning to fall. After keeping still for half an hour, they take vigorous exercise, as the explorers did on their march to the South Pole. How much difference do you think their clothes would have made? Why do you think modern equipment might be more effective? Would Captain Scott have been better off if he'd had a scientific eye? If you had been able to take part in the race to the South Pole, what advice would you have given Captain Robert Falcon Scott? And just how warm are your clothes?